Hello? Testing, hello. Oh, yep, I have audio. I do not know how to change the stream title on YouTube. I will poke Mermis. Alright, I am Numbers. We're going to be working on solving Mermis's CTF challenge. I gotta tweak some settings here. It's the first time I've streamed on YouTube. How's that for audio levels? Alright, and we should have video now. Yes, we do. So, oops. Pull down the binary. Let's see. 64-bit ELF as expected. Oh, well, that's annoying. Full rel row. Looks like he did not make it easy. Let's get this open in IDA and start taking. Actually, I should probably just run it first. See what it does. Let's go gamble. You currently have $100. Current high score is $101 by nobody. I have cards. So this is some kind of card game. Probably should just look at it in IDA and see what happens. So let's fire up IDA here. Give me a moment to get my IDA open and download this on my host. Okay. There we are. Thank you for changing the title, Mermis. Alright, we have symbols. That's nice. So, okay, so it's just going to call game over and over again. Main never returns. The init function is going to do some buffering stuff. srand based on ASLR. That is probably significant. And that, wait, is that, oops. Malloc. I don't know if that's a significant number or not, but that looks like a structure. Is that ASCII? It is ASCII. Nobody. Okay, that's the string that we saw, the nobody string. Okay. So I'm pretty sure this srand is going to be significant. I'm not sure off the top of my head how many bits of ASLR there are on 64-bit Linux for desktop. But if we can get like an ASLR defeat, then we can figure out what srand was and maybe defeat the RNG later. Reset deck is gonna unshuffle the deck, so I'm assuming, yeah. So deck is gonna hold all the cards. Oops. Reset deck is just gonna set them. This is a void. It's just going to set them and then zero out your hold buffer. Okay, so it doesn't do anything that interesting. It only does that at the beginning once. So the deck is not reset between games. So here's the actual game logic. Well, that's a bug. 19 characters. Well, wait, is that a bug? What's the malloc? 20? Never mind. Does scanf always null terminate? Let's Google that. I do not have the capability of showing my browser on stream quite deliberately. But I'm going to Google scanf null terminator. I don't know if it actually does. How big is that buffer? Yeah, I'm fine with that. And Hexarray seems to think that's fine, so scanf. Wait, 19s is, yeah, it's gonna null terminate. I'm being an idiot. Let's see. Print hands. Oh, that looks gross. So we need to make more dollars than the other guy, which means I think we only need to win once to hit this logic because he only has $1 more than us. Costs us $5 to play the game, and there's a cheat function. Oh, it just gives us. Can we just do that? Yeah, it just gives us a pointer. That's nice. So that just gives us a binary pointer, and then reads in two big. There's no bounds check there, so that's just an arbitrary write as well, which means if I can actually get this thing to behave. Yeah, so we just write from cards to dollars and insta-win, I think. So let's just try that in Python real quick. Oh, I didn't switch to my VM. I knew I should have tried to automate that. Cro-Magnon, are you asking about age? I don't know if Murmus actually is hanging around. Not sure. Yeah. Hi, I didn't really introduce myself. I'm Numbers. I'm a fan of Murmus, or a friend, sorry, also a fan. And I play CTF with him, and he had this idea to do this live CTF thing. I thought it sounded cool, so I'm going to be trying to solve the challenge tonight that he wrote. Yeah, sorry, I didn't introduce myself at all. I just kind of started. I didn't mess up the syntax there, right? Okay. So we're going to initially let's do def in game. So r dot send line 1337. Oh, me? I am also eternal, as Sean Murphy said. I am curious why you would want to know. I don't really feel like it's relevant. So then we look for this string. And then drop that new line, base 16. And just to be sure we did it right, I didn't actually do the thing. Yeah, okay. So that's what we're going to return from this function, and then we need to write to 1, 2. It's interesting. It's a 64-bit process, but everything is 32-bit values. I'm sure that's going to be significant. So if we write to, let's see, that's 60, that's 78, so it's 18. I'm going to get real annoyed by my virtual machine resizing itself because my hotkeys do that if I don't focus properly. If I can math correctly, then we just want to write to index 6. And this is going to read, where is it? Cheat. This is going to read a D word, or a long, 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 and then first one equals second one. So we'll do 6, comma, 1337, just to be cheeky. Oh, wait, it's still gonna, that's not actually gonna work, because once we do the cheat function, we still have to actually play the game. Oh, so I've been studying reverse engineering and programming since I was 14. I got into it, I used to do jailbreaks for the PlayStation Portable. Mostly my focus was on kernel exploits, although I did do some work for custom firmware development. I wasn't very good at it back then. And yeah, I've been doing it pretty much ever since then. But I started programming when I was 8. My mom bought me a book on Java programming when I was 8. But yeah, I didn't really get serious about like actually knowing how computers work until I was 13 or 14. Okay, so then once we've cheated, then it's going to, we need to give it a 0, and then yeah, so like that. Really? I don't think my overwrite worked. That is what that does, right? The cheat function should just be an out of bounds write on cards. Wait, how does the payout function work? Oh. Well, that's gross. I don't think I care about this right now. I'm sorry, guys. I just realized you can't see my IDA at all because being bad about switching between my views. I've got let me see if I can. Yeah, I've got like different views for my VM and my IDA instance in OBS, and I was gonna set it up so it auto switched on focus, but then I forgot to. So sorry about that. So yeah, the payout function looks disgusting. I'm not gonna look at it right now. From the looks of it, I should just be able to use the cheat function. Oh, it's cards. It's cards, not hold. So that's hex 78 minus hex 40. I misread. Switch back to my VM. If it seems like I'm doing stuff and you guys can't see, please yell at me in chat. I expect that that's going to keep happening until I get the hang of switching back and forth. So 78 minus OX40 is 14. Yeah, so title grid. The a lot of the Pwn Tools functionality is really nice. You can simplify a lot of your actual exploit logic through the functionality that they provide. I keep learning about new features of it constantly. There's a lot going on. I should probably like read the documentation someday. So if we try that offset instead, you're the new game score. Yeah, I have $1,337. Okay, so we're guaranteed to win. And then that gets us into the... Is there anything else we can do there? We can overwrite the actual winner pointer, the winner pointer itself. Does it ever tell us our name? Current high score by %s. So if we can only write a D-word value. So what we need to do is we need to set our money to 0, then use 2 hands to overwrite the top and bottom D-words of the winner pointer, since it gives us a pointer to hold. And then we'll point the winner pointer at the got, and that gets us LibC. Whoops. Murmus, I thought you said this was going to be hard. No, I'm kidding. So we're actually going to change this function. This function is going to become write BSS, or write data, and then index and value, and do global, that is the BSS. Right, BSS, global BSS, adder, put this up here. Okay, so what I'm doing right now is I'm writing Python that's interacting with the challenge binary. So if I go run this challenge binary that Murmus wrote, right, I can interact with it. I can tell it I want to hold card number 1 and then have it deal. I can interact with it. So I'm using a library called Pwn Tools, which should be in any hacker's arsenal, because it makes prototyping things so much faster. And all of these are, like this R value is a handle to that process, like I'm running that binary, and then I can send and read data from the binary. So like right here, I'm sending that line. So like if we were to run it, so this clean, I always kind of structure my exploits the same way. So I start off with opening the connection and then cleaning. And all of my functions will assume that they start at some central state, and then leave the binary in that state when the function is over. So if I need to call those functions in any order, they work. So that clean is going to read all of this text that comes out initially, and none of this do I care about, since I don't actually... Sorry, my bad. Forgot I put that comment there. I mean, I'm going to have to show it when I actually throw the exploit, I think. Okay. So, yeah, so then there's a cheat function, which is triggered by sending, when it asks you what card you want to retain, so you're supposed to specify 0 through 4, but it checks if the index that you specify is 1337, and there's a cheat function. And that function is going to give me a magic number, as it says, but it's actually just a pointer to the BSS. So I read that out, I turn it into an int. And then a host entry? Sorry, I don't know what you mean. And then the next thing in that cheat function is it reads in, yeah, hang on, I'll show it in the code again. So in the game function, there's this loop, right? And that's fine. I'm fine to like go back and show what I was doing. It reads in this v1 value from you, and if it's equal to 1337, we're going to call this cheat function. If it's greater than or equal to 1, then we're going to, set the hold value. If it's 0, then we're going to exit. And that'll loop until you finish. Wait, no, does that loop until you finish? Yeah, it does. Okay, so I can actually just cheat multiple times in the same hand. So the cheat function, when you get the backdoor, is literally just an out-of-bounds write in the BSS. And so everything that you want to do, I imagine this is the only bug in the binary. It's certainly all you need, given that there's a free info leak. This would have been possible to turn into an info leak. So like when it initializes your name, it's going to put a name pointer here. You probably could do a partial pointer overwrite and some shenanigans, but like I don't think this thing actually calls malloc more than once. I haven't seen any other calls. Yeah, there's just a single call to malloc. Oh, that's why it's hard. Bet you there's no calls to free. Yeah, there's no calls to free and only a single call to malloc, and it's full relrow. If this wasn't full relrow, like I'd have it solved. I would not be talking. I'd already have solved it. So okay, let's finish writing this boilerplate code here, so we can actually start looking at how we want to try to land this thing. So let's call this cheat, and we're not gonna do that send line 0. So, and then it's going to do, come on. So cheat or stir what s equals %d, comma, %d, format with idx and val, and then r.sendLine s. Okay, so we can actually call cheat multiple times on the same hand. There's no limit on how many times we can cheat. Where can you read more about info leak bug? You mean like how to do info leaks in general? I don't really know. Maybe somebody else in chat can help. I mean, this one, the info leak bug is free. Like, he just gives you a pointer. Oh, full relrow. So what full relrow means... what full relrow means is there's all these GOT entries, the global offset table, and these are how ASLR is implemented on Linux. So the binary needs to call these LibC functions, but LibC is going to be at a randomized address. So the linker is there's going to be these relocation symbols emitted in a section called the global offset table, and the linker is going to fix up those to point at the actual functions once everything's loaded into memory. What relocation read-only means is after all of those are written, then that segment of memory is made read-only. If it wasn't relrow, then you could just write there, and the next time it calls that function, it's going to use your data instead of the original function pointer. So like a classic way to do that would be like, in this case, we would probably, let's see. we would probably just like bash puts to the magic gadget or something like that, because there's no super obvious places to get arbitrary code execution otherwise. Oh, okay. So in this binary, there's this, which is free. If we didn't have that, we have the cheat function doesn't bounds check when it writes whatever value we want into the cards array. So the cards array is in the BSS. Well, actually, I don't think that would work now that I'm talking it through. What I was originally thinking is that you could partial pointer overwrite this winner pointer. A partial pointer overwrite is where you only overwrite the least significant byte or a little bit more than that of the pointer instead of the whole pointer, and that lets you move the pointer instead of overwriting it entirely. But because we're writing a D word, we're writing a 4-byte value. I actually don't think that would be viable. You might be able to go. So there's some shenanigans you can do. I've not actually done it, but I saw Murmis do it, where you, well, no, that's just the pointer to the structure. Yeah, I actually don't think that would work. I think you do need the info leak or another bug. I think that's why there's the free info leak, because otherwise there would have to be another bug, unless you did something really clever, which nothing's really coming to me right now. But this right here, these two lines, look to me to be the only bug in this binary. And it should be all we need. So I'm not calling the %p BSS pointer that we get a bug. Like, that's technically a feature. Okay, so then we're gonna do. What was I saying we're gonna do? Yeah, we're gonna write the name pointer to the BSS or to the GOT and then lose. So def info leak. So first of all, we need to fix this. Let's switch back to IDA. So it's printing. Oops. Come on, IDA, please. Okay, it's giving me a pointer to deck, which is at 202.080, and the base address of the BSS is 202. So I just got to subtract hex 80 from that pointer to get the base address of the BSS. I'm going to change this to offset just to make things easier on myself, and do idx equals offset divided by 4. So then we're going to subtract hex 80 from that and change this to be BSS adder. Okay. So the info leak that we're going to do is we are going to write, where is, oh, screen, yeah, thank you. So let's look at the BSS here. So we need to overwrite the winner pointer, so that's at hex 150. So wait, what's the order of operations here? Because I need that value. So let's just be lazy and do cheat 0 0, and that will set BSS adder. I could write better code than this, but I'm not. I have to do that because the arguments to the later calls to cheat are dependent on this variable, which is set in the first call to cheat. And then we're going to cheat OX150. What is the relation between BSS and the GOT here? It's probably easier to do in GDB. So the got is however much that is beforehand. Let's confirm that in GDB. Yeah, and if anybody's not, if I start going too quickly and anybody's not following things, I'm glad to slow down and explain. So let's break on main, run. Let's get, okay, so we get the address of the cards. What's the first item in the BSS is, or the got, I mean. Sorry, PyPony, I thought I had gone back and explained it. So the var index value in this case, when I went back and looked at it again, couldn't really be turned into an info leak. Because you're writing 4 bytes instead of 1 byte, the technique that I was thinking of wouldn't really work. In this binary, the info leak is free, though. It's given to you. It just prints out an address to the BSS. That work? Okay, that's not helpful to me. That's going to be BSS. So let's do like minus 100. Those look like libc pointers. The right address? Yeah, it looks like it. So we want to start, we'll do here just to make it simple. Please increase the size of the code. Oh, in IDA or on my screen? I can adjust my resolution a little bit. I should be streaming in, I'm only streaming in 720p. I thought I switched it to 1080p. I was originally going to be streaming in 21:9, and then I looked at how it actually looked on video and decided very much not to do that. So this should be, yeah, it's stir copy. So if we point, right, do you need the size of the code in IDA or in the VM fixed? Because I know my Emacs font is a little bit small. I actually don't know how to increase font size in Emacs. I gotta Google that. Yeah, 1 second. Increase font size Emacs. Been using Emacs for 4 years, and there's still times I have to Google things. Control-C, Control-plus. That's not right. Oh, Control-X, Control-plus. Is that better? That looks better to me. And actually, because this one is proving to be simpler, I can just put both of these on the same screen. So I don't have to be swapping back and forth so often. I usually I use Awesome Window Manager, and I'll use the different workspaces to hold my different stuff, because typically in Emacs I'll have like, I don't know, 3 or 4 different text buffers open side by side, so it takes up my whole screen. But with just one for this exploit, it doesn't matter. Okay, so then we want to do, I was calculating the offset to this, which, being kind of lazy and just letting GDB do the math, so minus 70. So BSS adder minus 70, and I need to only do top bytes. shifted by 32. And then we're gonna do cheat OX 150. Oh wait, I need to do cheat 14.0 to make sure that I absolutely 100% lose or I'm gonna crash. And then 154 BSS adder minus OX 70, and that doesn't work in Python. Like that. And then r.sendLine 0 to end our hand. So let's try that out. Just wrote a bunch of code without testing it, so no idea if this is going to work. Let's see what went wrong. Well, we can attach GDB and check it out. And then also, just write a magic value so it's easier to find. And do that. Open up another terminal. Attach GDB. BSS is, I don't know what it stands for, but it's the 0 initialized data segment of the ELF. So if we look at the VM map, this writable page is the BSS and the data segment. Any writable global variables are stored in that page. Okay, so what was I doing? Oh yeah, so we can use the PETA search mem feature. So we did write to that, but clearly that's not the right block started by symbol. Okay, so clearly that's not the right offset. Let me check IDA again. There's no reason for me to switch. Wait, I did 190 instead of... Did I not? Is that not right? Cards. So we're writing to cart. Are we writing? No, we're writing to hold, which is at OX 60, not OX 80. Switch back. So we're writing to this array. So the BSS should start at 20. Let's see. Yeah, it should start at this page. Let's just confirm that by doing something dumb like comment all these out and cheat 0 dead beef so we can find that in memory. That's not right. There it is. Okay. So, hello F4H4M. Oh, screen. Sorry. Thank you. I've just been poking in GDB, so I just wrote a magic to cheat -1. So I found it, and then if I do telescope that, let's do like 40 of those. So there's the cards array. Oh wait, I need to do like, let's make this aligned. Yeah, there's that pointer, which is at 150 as I expected. That's at 40, so I like completely messed up reading IDA. Oops. That's where my error was. Oh, are you buffering? I'm not showing any drop streams or drop frames on my end. There are encode options. So telescope is a PETA feature which will print out all the values in a range of memory and also traverse pointers. So if there is a linked list, it will traverse the linked list. It's one of my go-to lazy commands when using GDB. Okay, so it was this value right here. I misread IDA, and that's why our code didn't work. So if I do this, we're going to insert a pause so I have time to attach my GDB. Is that PDB? This is GDB PETA. The GDB extension, you mean? I think PDB is pwn_debug. I do have some pwn_debug features that I cherry-picked from the tree, but I prefer PETA's interface, probably just because it's what I started using originally. So this should crash on 4.1. It didn't. I messed up again. Luckily, I can do math. C. Maybe I can't do math. Maybe I'm just really bad at math. Oh, PDB is a debugger for Python? No, this is GDB PETA. So this is just GDB with a Python extension called PETA, which I will link in chat. It makes GDB almost usable, almost. Try removing any web addresses. Cool, I'm not allowed to link things. So I am working on a challenge that was written by Murmis. There have been a bunch of us attempting to solve it. I'm currently bad at math because I keep talking instead of just solving the binary. So if you'll let me shut up and hack for a minute. So that should have written that magic. I find GDB to be pretty unusable without PETA. Or an extension of some kind. It's dead beef. There's PETA, there's pwn_debug, there's Jeff. I'm sure there's plenty of others that I'm forgetting. So 3C, it should be at 4.0 would be the cards, right? Yeah, so why? Why am I bad? I subtracted 40. What is the cheat function actually giving us? Cheat function is giving us dec. So, yeah, that's my bad. So dec is at 80 like I had originally. Oh, right. Am I fixing things up? Yeah, I'm doing offset divided by 4, which means my -1 is still -1? How is -1 divided by 4 -1 in Python? That's weird. It is true, Sean, that a lot of things break. You'll notice I am use work with pi in GDB with PETA. Okay, int over int equals int. Okay. Well, it was sending the value that I wanted it to send, so that's fine. So I should be doing -80. No, it's giving me dex, so that should be minus 80. And then the other stuff is not 0 based. Yes. So I need to take my offset and subtract OX40 from it. Or add, wait, so yes, subtract OX40 from it so that, sorry, I'm operating on not enough sleep and very much failing to do math in my head right now. I'm just going to do this the really lazy way. So I know that it's at OX44, so I'm gonna do offs and do that, and then OX44, OX48, and then this should crash, and if it doesn't crash, I'm sad. I didn't save. No. That doesn't make sense. That doesn't make sense at all. Okay, let's look back at the binary, because clearly I missed something. So it looks like I'm cheating multiple times. Yeah, I'm getting my magic number multiple times. What is size of D word in IDA? Because shouldn't Hexrays be putting a cast here normally? I'm looking at IDA now. Wouldn't Hexrays typically put a cast here? Or is it just ignoring the implicit integer truncation? What does this look like in assembly? Yeah, it is just a move ECX. Where, yeah, so that should be working. I don't know why my magic value is not showing up in memory. I'm clearly missing something. But what? Alright, you know what? We're gonna do something real dumb. If this doesn't crash, or at least my A's don't show up, like, need to show up in memory. Oh, damn it, screen. My bad. Okay, so for whatever reason, I can't find where my values are being written. Just my offsets are wrong. So I'm writing A's to the whole thing. There we go. Okay, finally crashed. That is what I expected. What did we crash on? Racks. What even are those values? I never looked at the payout function. So I've clearly overwritten my card names with the letter A, which is what I expected. So if I do shrink this, hopefully there's some number of A's I can crap all over this thing, and it will crash in the way that I want instead of in the function that I really don't want to look at. Oh, I need to change this down to like 16. Oh, maybe, you know what I bet it is? I bet you the cards buff. Yeah, payout reads the cards buff and does a bunch of crap on it. There's some other buffer that it's using for calculations, so because I've overwritten it with invalid card values, it's crashing in here. It's never going to get to the next step. So I need to... Oh, hang on, sorry. Okay, so this crash that I'm causing right now, I'm overwriting the cards buffer, and the payout function is doing some stuff with the contents of the cards buffer, and then doing a bunch of other stuff, including other indexing and stuff that I don't care about. But what this means is that the contents of the cards buffer are used in some calculation that's involved with indexing, so I don't want to overwrite that right now. So I need to go to the BSS and say, let's just switch back to my code and keep being lazy. Oh, yeah, hang on. Yep. So I think that's under options font. Like, get like that. Oh, that's way too big. I can't read that. Let's do like, is that better? I made it like 4 points bigger. Are you on mobile, Cro-Magnon? I'm working on drop iOS Ode, please. Thank you very much, David Menaucherry, for the donation of $2.79 Canadian to Murmis. I am not Murmis, but I'm sure Murmis appreciates that quite a lot. Yeah, sorry, Cro-Magnon. I'm working on my laptop screen, which is a lot smaller than I'm used to. So I'll leave it like this for a little while, but if it starts to disrupt my ability to like figure out what's going on in a function or something, I'm going to shrink it back down. So I need to remove the offset divided by... That doesn't make any sense. The hold buffer is after the cards buffer. So why... Oh wait, I'm writing to the cards buffer. Right, it lets me just change the deck. This is Numbers. I'm a friend of Murmis's. He wrote this CTF binary, and a bunch of us have been streaming ourselves trying to solve it. Yeah, so I can just directly control the score, Bad Bites. I've already done that. What I'm trying to do right now is overwrite something else in the BSS, and I'm just potatoing all over everything. I should have had this 20 minutes ago. But something is clearly not behaving the way that I think, because... So we're going to take out this calculation, because maybe Python division is what's messing me up. Change that to that. Now this should only... That's okay, that's writing inside of the cards buffer. So there's... There's 8 D words of cards. So we're going to start this at 8. Well, we can start it after hold. There's 8 D words of cards and then 5 D words of hold. So we'll start it at 8 for now, and write 8 D words. I think it's just me repeatedly misreading the binary because I'm trying to multitask. Let's see, killed. Where's my... Oh. Let's change that. Doing so good at the beginning. Okay, so that overwrote what I expected. Like if I oh goodness, I'm sorry. If I do hex this value, yeah, okay. So simplifying my code and not writing to the cards buffer got past that crash. Now if I make this like 24 or something, this should definitely crash. So that's saved. Why? What am I missing? So that should have overwritten. Oh, there's deck. So it's actually probably quite a bit bigger than I thought it was. It's 52. So PyPony. So the shifting and whatnot, that's because I'm writing a 32-bit value, but I want to set a 64-bit value. So I wrote the high 32 bits first, so that's why I had to right shift it by 32 to get the high 32 bits of that 64-bit value into a 32-bit value, and then I ANDed it with, you know, not 0 or whatever, so 32 1 bits, to get just the lower 32 bits. And the division by 4 is because I'm indexing into a D-word array, and I was trying to be fancy, but my code wasn't working, so I'm not doing that anymore. I'm just writing directly now. There we go. Thank God. That's what I've been expecting. I don't know how I managed to mess up my... offset calculations so badly before. So now I'm going to do like f equals cyclic, whatever. I don't want to have to worry about how long my cyclic is. And each of these is going to be U32. What is the command? I want an integer. So, yeah. Is it U32? Yeah. So then U32 cyclic, f x through x plus 4, and that should give me a cyclic here. Whoops. Okay, yes, that did what I wanted. So then that's that value. Python or cyclic find that. So that's 68. So 8 plus 68 is 76. What is that in hex? I was dividing by 4 when I should have just been using the actual value that I calculated. I'm real dumb. So now, if we cheat 14.0 to set our money to 0, cheat, wait, that needs to be, no, it is just 14. Yeah, cheat OX, that's the high D word, so it's 4.8. And then cheat OX 4C. This should crash just on A's while writing a lot less memory. It didn't. How did I screw that up? Cyclic is a PwnTools feature that generates a string such that when you get data from that string in a register, like I did here. You can take that data. Wait, I was already starting at. Didn't I do that math? Didn't I do? So I was starting at 8, but so cyclic find was 68. So I added 8 to that to get 76 because I was starting at. Wait. That 68 needs to be divided by 4. That's what the problem is. Yeah, so it's 17 plus 8. That doesn't sound right. Only 25. We're writing to cards. We want to get to winner, which means we have to go past this giant array that's deck. To go past hold, winner dollars, dollars, deck. Let me just check what I was going to check. See if my bytes got written in somewhere. Yeah, they did. Okay. So I can easily just calculate. Oops. Is it not? Thanks, GDB. So I am off by, oh, I'm only off by like hex 10 bytes. So 4. So it's 4 through, or OX40 through end OX44. Yeah, that sounds vaguely correct. If it's not, I'll just shift it again. Hey, there. Okay, so it's 4 and 4 This should give me exactly the crash that I'm expecting. It's 4 and 4. The indexing by D word and not by byte is really messing with my head. Yeah, there we go. Okay, so that's the crash that I've been trying to get for far, far too long. So now I'm going to change these to be BSS adder, those values that I had before. So BSS adder minus OX80, right shifted by 32. And then that same value ANDed with that. Crashed. That's probably fine. Let's find out why. I am not sure what that value in RDI is. Is this like Python doing something really weird? Let's try that. Take it off debug mode. Yeah, so that's the printf we're in. So RDI makes not much sense to me unless some of those bytes are bytes I'm expecting, which they are, which means I am just off by... I have them backwards. That's the problem. Easy mistake. Where did it print it? Right there. Ah, okay. So that needs to be minus OX78? No, wait. Yeah, 78, not 80. Ah, there we go. Info leak. Boom. Whoop. So that, my friends, is a libc pointer. Git commit exploit.py attack m get libc leak. So now we just need to deal with parsing the rest of this data. So we want r dot receive until 101 by, and then that's going to print 6 bytes. So r.receive 6 bytes plus the 2 null bytes that we missed. And this whole thing needs to be U30 or U64'd. And then print hex libc adder. Yep, that is a libc adder. Cool. Okay. Not yet. Cro-Magnon. I was just able to read a pointer to libc. In this case, I think it's printf or something. I'm gonna check in a sec. I just want to, where did I write that down? Grab this IP address. Don't need the HTTP part. There we go. So we don't need to print that anymore. So we are at 2A0. Oops. And the remote is at, that blows, 810. So the remote has a different libc than me. So one of the ways you can tell is looking at the last 12 bits of any given pointer. Because ASLR is, page aligned, it only randomizes bits above the lowest 12 bits. So if you have an identical libc and you have 2 ASLR pointers to the same function, then those last 3 digits are going to match. The remote does not match mine, which means I need to identify it, which I can do fairly easily. First off, I need to figure out what I'm actually leaking, which is pretty quick to do. Just leak it, and then get it. Leaking an address to putcar. So I know that this, there is a command line tool for this, but I'm going to use a browser tool. I wonder if this is worth showing. Give me one moment, I'll put this up on screen. Hide bookmarks bar. That looks fine. Alright, so add a scene. And editor. In that scene, add a window capture for, oh, hello. That's not what you should be showing. One second. Oh, why are you not showing up? Why is Chrome not showing up in my OBS capture? Crap. Alright, we're gonna... Can I do this without switching to that scene? Dang it, I want to switch to that scene. Do you guys care seeing how I identify the LibC? I can just talk through it. It's probably easier to see. Alright, I'm just gonna add a... Oh, this is... Yeah, okay. Display capture on my primary display. Why are you still black? Ah. Come on. I don't know how to OBS. I don't have Firefox installed. I don't use Firefox. I've spent enough time hacking around inside browsers to be pretty terrified of using anything except for Chrome. And even Chrome is sketchy, if you know what you're doing. Okay, well, I can't get this to display. Oh, I am dumb. I'm real dumb. Because I have, whoops, sorry guys. Stream is doing the thing. I have this VM that I've had for 700 years. I don't have Firefox on it. But I have a Firefox that I built from source. Hey, we have Firefox. Okay. Knew this Firefox that I spent literally almost a month trying to build would come in handy someday. So, LibC database search. So this is an awesome website, which is this guy, libc.bluecot.me. I can never remember that URL. And the way this works is you tell it a symbol. So far we have putcar. And we know that the least significant 3 bytes of that putcar are 810. So we tell it that. And we click find. And it tells us that there are only 2. So I could go and, find some more symbols. But looking at these 2, one of them is i386. And I know that this is not i386. So I know for a fact that this is libc6 2.73 Ubuntu 1 AMD64. And not only can I do that, from the same page, I can just download it. So now, I'm going to hide my VM for 1 second while I tab complete in my downloads folder, because I have no idea what's in there on this VM. CP download / yeah, that is a good thing that I hit that. CTF / libctf. Drop that in there. All right, back to the VM. So now I've been using the same VM for all of my projects and CTF and quite a bit of my job as well for way longer than is reasonable. Okay, so now I have this libc, and hopefully I can just ld preload equals /libc chow. I can't. Well, that's fun. So I can't run with that libc. So I'll just land it locally and then port it over. I'll show you guys that process. It's not that bad. Okay, so let's get back to this. So we can do, there's this command called xinfo, which I only found out about recently. Let's continue this. Yeah, 1 second. I don't want to lose my train of thought. 1 second, bad bytes. Offset. There we go. That gets us the libc base. What is it on the server? Let's just start writing these down so it's a faster thing here. I don't usually write my exploits this meticulously, but I'm trying to show good practice since I am showing off to the public. Okay, so now, whether I run it locally or I run it remotely, I should get the libc base address. So let's just comment that out because we don't care. Looks like a base address to me. What about remotely? Also looks like a base address. Cool. Okay, so the way that I like put car is the binary just straight gives me a pointer to the BSS. Whenever I cheat, it just prints a pointer to the BSS. That allows me to calculate the address of the GOT, and then I use my BSS write that I have, my BSS relative write, to write the address of the GOT into the okay, sorry, I wanted to make sure my Slack notifications weren't showing on stream. Quit. That allows me to write a pointer to the GOT into the name pointer, and because I've set my amount of money that I have to 0, when it prints the name, which it does every game round, at the beginning of the game, it will print who has the current high score. So because I've bashed this pointer right here, winner, I've set this to point at the GOT. So when it does this %s, it prints me a pointer to libc instead of the original string name. And this is where it gets tricky. So we also have an arbitrary write. So we have this right here, this stir copy. Oh, it's a stir copy. Okay, so we can write up to 19 bytes with no null bytes to anywhere we want. And we have the libc base address. But it doesn't call malloc. It never returns from main. It's full rel row. So the question is, how do we actually exploit this? And this is where this challenge gets interesting. So to show that I have an arbitrary write, let's do something like oh, it's not running. Back on interactive, and then do global libc adder and then set libc adder there, print it, and then clean. Okay. Oh, screen. Sorry. Thank you. I was just cleaning up my exploit a little bit, so I added libc adder as a global. I added a clean to the end of this function. so that it's back in the state that I would expect it to be at. So cheat will work and whatnot. That is not Python. Like that. So the next step, let's take a look at LibC. This is where I'm not sure what I'm going to do next. So to demonstrate that we have an arbitrary right, so let's write an arbitrary right function. So let's do like def right string s adder. So the first step is going to be to cheat 14.0 and then cheat x45. I'm just going to copy this code. I'm lazy. Just modify this to be adder. So we're going to do the same thing we did before. I'm cheating 0 here because I want to future-proof my code against interacting with any other functions that I might write. And if I happen to win while I'm doing this overwrite, I'll crash. The right number of parentheses. Yep. Okay, so then we're going to cheat that way. That will bash the name pointer to be anything that I want. And then, no, I guess I just want to win now, so I don't need this. I'm going to cheat 01337 for the swag, cheat 14 I mean, give myself lots of money, and then send line 0, and let's do like r.interactive there, and then we'll do right string, cyclic, looks 10, and x4141414141414141. So this should crash attempting to stir copy with the destination as 4 ones, assuming it has no typos in it, I mean. How am I doing on time? Oh, I'm doing fine. Okay, so now I get to enter my name. If I break and I print winner, winner is controlled. So if I actually enter a name here, like, we're going to segfault writing to my controlled pointer. Is memmove on? This program doesn't use memmove. So if I wanted to say magic, wait. I just thought of something kind of clever. I don't know if this is going to work, though. Can I pull that off? I think I can. So what I can do, stay with me, is I overwrite the malloc hook, and then I overwrite the name pointer again to point at some very large section with no null bytes somewhere in libc, and then when it calls printf, it will call malloc, and I get code execution. This should work. I've always wanted to do this in a CTF challenge, using printf to call malloc. So we're gonna write to libc adder plus malloc hook. Oh, screen. So malloc hook is at that offset. I wonder how much my chat delay is, because I changed it a good 30 seconds before Enimawani 111 said screen. So the malloc hook, free hook, realloc hook, and a few others are called internally by malloc.c in libc. Malloc hook is called before malloc, free hook is called before free, realloc is called before realloc. You get the idea. These are writable variables inside of libc. There are actually libc exported functions to set them. So if we have an arbitrary write and the base address of libc, we can write to the malloc hook, and then if it ever calls malloc again, we get controlled program counter. But the thing is, this binary doesn't call malloc. The other thing is, printf calls malloc. So there are only 20 POSIX or libc functions, 20 libc functions which are safe to use inside of a signal handler, because very, very, very many functions can internally call malloc or free. So what my plan is to bash the malloc hook and then set up the winner pointer again to point somewhere in libc that has a very long string with no null bytes. It could just be a long section of data with no null bytes. And then when I lose the game again, it should call printf. I mean, that's something that's quite easy to test, Hyper. So we'll do, test.c, include standard lib.h, include standard io.h, main. So we want to do underbar malloc hook equals ox414141414141. We'll do car a, start with like a page for int I equals 0, I is less than 1000, I plus plus, ai equals a, printf %s a. Okay, so what this should do, there's actually, so if I thanks, Sean. I mean, it wouldn't have made a difference either way. It's going to set it to a character that's not 0, but where am I missing a colon? Printf? That's got a colon on it. Or a semicolon, I mean. Oh, comma. Yeah, thank you. So there's actually a variable. It's depending on the build configuration, and I didn't think it was worth the effort to track down the default libc configuration. There is a variable which is the vs printf malloc threshold. It is set to, actually, I'm pretty sure it's like 6.5. I'm pretty sure it's max unsigned short. Now that I'm saying it, I looked into this a while back. I was trying to write a binary where this sort of thing was the goal. But let's just compile this real quick. Come on. Oh, malloc hook is undeclared? Where is that actually declared? I probably need a header. I need to include malloc.h. Also, if you use these for non-hacky purposes, you're doing something wrong, and you should reconsider your life. Yeah, so it's site-faulted. Why did it say fault? Did I mess something up? Oh, because the first time printf is called, it will malloc. Oops, I need to recompile. Yeah, so the first time printf is called, it'll malloc. Okay, so let's make this 16 pages. Let's see what happens. Please crash. Probably should have like redirected this to dev null or something. Yeah, I'm gonna do that. No, we didn't crash. Holy cow. Okay, let's make it like an obscene amount of bytes. Title grid. I've been playing CTF fairly seriously for, I think, close to 5 years now. It's at least 4. And you pick these things up a lot of the time from failing to solve a challenge and then reading the write-up and being like, oh, that's such a cool technique. I often say like being good at CTF is partially just about being good at just amassing arcana. Like I know so many obscure things about LibC. It's kind of painful. I am currently playing for what the heck are we calling ourselves? Anyone in chat know? We were last year. We were Spaceballs. We played DEF CON finals, which was cool. Yes, I don't care because the low byte of the address of the string is almost certainly not 200 or 8-bit aligned, so it would set it to, you know, it would set it to a non-zero value, Sean. But you are correct. Oh, I need to redirect it. Please crash. In a moment, I'm just going to pull up the libc source and we can check. Yeah, I work with several of the people on Spaceballs. I used to work with a lot more of them, but I don't have that job anymore. I played with Mammon Machine for the 1 year that was a thing, and then for a year. Oh, that is a good point, Christian. Let me check. Nice. It is. All right. So optimize this compiler. Good call. Thank you. BRB puking from AT&T. Oh, yeah, like the syntax. Apparently it does. I never use objdump. Usually if I use objdump, I'm being really lazy. This would be, at this point, faster to just check the source. So I'm going to do that. Let's open up a new Emacs. Hide my screen for a second while I navigate to it. Okay, this is malloc.c. We also want where the heck is printf.c? Gotta look this up real quick. Printf libc source libc /printf.c. Doesn't sound right. Yeah, I need vs printf. I can just do, come on, helm. Oh, if you need a single excuse ever to switch to Emacs, there's this function that I'm about to use. I do have gtags here, right? Hopefully. Helm gtags do what I mean, where I can just type in definition, and it takes me to the thing that it thinks that I mean. Oh, my resolution is pooping. What is happening? Oh, okay. Somehow my view of my stream just dropped to 240p. Is it good for everyone else? It's going to call that. It's going to be IO vs printf, which is going to be this one, which is... Okay. Yeah, mine did the same thing. YouTube probably had a thing because I'm at 0% dropped frames in OBS. Where is the actual declaration of this? Or is this one of those weird things that... It's this right here, this weak alias. So get this weak alias, and that is the function definition. Does that function definition... That function just calls into the thing that I was at a second ago. The heck? I know I found this in the past. Hang on, I'm just going to Google. So I know what file to look in. I need vsn printf. That doesn't seem right. Well, it's using... The LibC source is real jank sometimes. There are things that make you question your sanity. Like, I'm fairly certain that vsn printf, or do I just want underbar vsn printf maybe? No. Does anyone know where the printf source is in glibc? That'll do. There we go. So I'm looking at printf right now. So the way that I'm planning on getting program counter is by overwriting the malloc hook and then coercing printf to... Well, the binary is full rel row. I don't have a stack pointer leak. There are very few other ways. Like, the intention of this binary... I know it's full rel row by accident, but at this point what makes this binary interesting to solve is you have arbitrary write into libc without any of your standard primitives. So you can't use the virt.io overwrites. So there's like standard in, standard out. Those structures in libc have vtables. But since quite a few libc versions ago, those vtables are now hardened. They're checked with a cookie. So you can't overwrite those vtable pointers and get program counter that way. It doesn't call malloc and free directly, which means you can't get program counter through those hooks. And those are really the only techniques that I know for getting program counter from an arbitrary write. If this doesn't work, I have plenty of time. If I can't get printf to call malloc, I'm going to do something that Murmis has been telling me to do in pretty much every CTF we play. I ask him a question, he's like, just write a script and test it. So I'm going to write a script that will write a keyword of 4 ones to every 8-byte offset in libc and dump all the registers to JSON and then see what we get. But we'll get to that if this doesn't work. Man, this isn't the function we want either, but I know it's in here somewhere. So VFW printf. Do I not have a declaration for that somewhere in here? God dang. What is the name of this symbol? I can just try to remember. Oh, right. I'm in the wrong place. /vf printf.c. Ah, okay, wait. This is the right function. This is the right file. Yes, okay, I found it. So let's see where our calls to malloc are. They all check against the same calculation. So there's this libc use alloca, which determines whether it wants to put the temporary data for printf on the stack or on the heap. And that's going to depend on max alloca cutoff. So it should be 65536, which is what I thought it was earlier. So if we printf 65536 characters, or is that the number of characters in the format string? Let's take another look at this. Something I've always wanted to do, this particular exploit, coercing... I mean, what do you mean by that, PyPony? Macros are fast. It depends on what's fast. Okay, so we look at... Where are we? We are... Oh, geez, this whole thing's a macro. I just noticed all these backslashes. Oh, that hurt a little bit to notice. Not entirely bad bytes. The C preprocessor is Turing complete. So the way that I've done this in the past, so like if I do like printf %o 65537d and then some value. Yeah, now that's seg faults. So I know that the value that you supply in here can be used to trigger the malloc. What I don't know for sure is that the value to %s can be used to trigger the malloc. Actually, it probably can't, because why would it be writing it anywhere? It's just going to write it to the buffer. It's just going to write it to whatever file descriptor printf is going to. So let's take another look at the binary in IDA and see. Animalwani, I'm actually honestly not sure. I saw a paper titled C preprocessor is Turing complete and groaned and didn't read it. So I need... So that %s is not going to work because it's only going to... It's just going to dump that stream directly to standard out. Oops. And I think... Oh, wait. What about scanf? Right? Because that data's got to go somewhere. It doesn't specify how many characters it's going to read. It's just going to read till it receives a new line. So like if we... Oops. Never thought about using scanf for this sort of thing. But it might work. Let's test it out. So if we do test equals 0, and then we, the heck are the arguments to scanf? Format and then pointers to stuff, yeah. Scanf %d, comma, %test. And then run it. And running out of buffers. Give it like a ton of characters. Oh, why did you segfault immediately? Oh, wait, that's a good thing. Scanf calls malloc. Printf does use malloc PyPony, but I can't hit any of the conditions under which it uses malloc. If you're curious more, I would suggest reading through the source. Check out what directory am I in? Check out libc source / or check out libc whatever / stdio common / vf printf.c. Yes, I did. Bad bytes. I always put my compile and run commands on the same line so that I don't make that mistake. So scanf calls malloc. That's right. Like if I backtrace, I should see. Yeah, that's quite interesting. So actually, is that because it's the first time that it read? Let me try. Because a lot of these will call malloc during their first time that they're called because they have to initialize some of their internal data structures. If you had to initialize every libc feature at the time libc is loaded, it would take you hours to load libc. Okay, so that time, yeah, it was the initialization. So let's try giving it just all the bytes. Okay. Yeah, nice. Okay, cool. Murmus is going to like this one. Wonder if anybody else came up with this technique. So, want to write to the malloc hook. We'll start by writing just some junk there. And then once we've done that, this shouldn't crash. Okay. So then r dot save until enter your name, and then r dot send lines s. Let's add a sanity check. If len s greater than ox1f, print cannot write so many byte dip exit 0. Okay, so we're gonna write a's. And this really shouldn't crash. Nope, it did not. And if I attach GDB and do x/x underbar malloc hook, oh, I did it wrong. What did I do wrong? Well, I've got 4 ones in LibC, but what did I write them to? I wrote them to the wrong symbol. That. Let's just do this the old-fashioned way. I mean, no, PyPony, that would not be why scanf is dangerous. But it's no more dangerous than any other libc function that's going to call malloc, like lots and lots and lots of them do. If I was allowed to link, there's a great article from, like, I don't know, longer ago than I believe I've been alive, which is discussing the fact that you really, really cannot use the vast majority of libc functions inside of a signal handler, because if your heap is corrupted and you get a seg fault, and then you go into your signal handler and you use one of your libc functions that's going to use the heap again, that is technically exploitable. I am aware of at least one case in human history where a situation like that has been exploited. Okay, so the malloc hook is maybe not at that address. So let's look at where is the libc base? libc base, I did leak it correctly. It's good to confirm. So we wrote to this address, and that address is, oh, I'd have this right here. Am a dum-dum. There we go. Okay, so we control malloc hook. So then we're going to do r.clean. So once we've written to the malloc hook, I think then all we have to do is send it a big-ass line of zeros. Let's try this. Ah, nice. All right, I got program counter. The reason it looks like I didn't get program counter is because where is it? This instruction, or whatever, the actual instruction that's trying to load program counter is seeing this value, and this value is not a valid value for that thing to load into program counter. So if I change this to like P64, like that, right? Least significant bytes. And it's not going to write the zeros, whatever, you'll see. And then do like that. Yeah, there we go. Program counter, git commit exploit.py tag m 41414141 pc. Cool. Now it's pretty simple. Oops. Like, I'll land it locally real quick and then switch over to working on it remotely. Let's check one gadget. Really should update that so it stops taking so long to run. What do I need? I probably should have left my debugger running. Let's get this back so we can examine it. Okay, so RSP plus OX30. Won't work. What about 40? Won't work. 70? Won't work. And, well, that's annoying. Apparently, none of our one gadgets are going to work. Right? Maybe I'll try updating it. What was the command to update it? Maybe it's better now. Gem update one gadget. Probably got to sudo this. So there is an address. I really should have been recording locally, so I had this for myself. Mark US. These are being recorded. Murmis is going to put together a highlights reel and like a recap video explaining, where everybody got tripped up, all the clever things everybody did. And I have to imagine if people are demanding it, he will release the VODs. Bad bites. The first one won't work because it requires rax double equals null, and rax is actually my program counter value. So you run into this kind of situation periodically. So if you're not familiar, if anyone's not familiar with the magic gadget or one gadget, there is an address inside of every 64-bit libc, or actually several addresses, where if you put program counter there with certain constraints, so the 4 that it listed are, for the first one, rax has to be null. For the second one, RSP plus 30, hex 30 has to be null, right? If you meet these constraints and you point program counter at that offset into libc, you just get a shell. It is partway into some function, which is intended to call execve, and the state of everything at that point in the function is such that it just drops a shell for you. So let's check one gadget again. Let's see. See, RBX. I guess if I did a leave ret, right? Because leave would, no, that's RBP, not RBX. Never mind. Let's try the one from the server. Oh, I killed my binary. Dang it. Okay. So, oh, RCX. Dang. Okay, so none of them are going to work. So that's not a problem. Let's see what we can do here. I will start in another terminal. And do Python, or go back to my VM. Rob gadget, tac binary, the libc from the server, to gadgets.txt. That's going to take an eternity to run, which is why I'm starting it now, in case I need ROP gadgets later. So I can't call, I can't just call system, because from the looks of it, yeah, none of that is interesting. I can't use one gadget, so I'm just going to have to write a really short, simple ROP chain. It won't be a problem at all. The best way to contact me myself, I am on Twitter. I don't really check it a lot. I mostly use Discord. Let me pull up my Twitter URL. Where's my, how do I access my profile? I don't have what? Oh, I can change that. I don't know if I want to change that, but I'll experiment with changing it. So how do I change that while these gadgets are generating? Actually, I'm going to put, one sec, let's put that up on screen so I can see it. How the heck do I change direct message settings? Edit profile, maybe? No. Cancel. Look on my profile. Settings and privacy. This should be it. Muted accounts, muted words, blowing out, notifications, privacy and safety. Privacy and safety. I don't really care to tee it. As soon as I see it finish, I'm just gonna open it up in Emacs. It dumps them all out at once anyway. RopGadget doesn't actually emit them as they're found. So it's just gonna hang for a while. So I'm gonna attempt to just write a RopGadget for the remote server without testing it locally, because I don't feel like writing two different ROP chains. So that should be fun. Privacy and settings, direct messages. Am I just fucking blind? Sorry for swearing. Privacy and... Oh, wait, I have privacy and safety. Ah, here we go. Direct messages. Sure, receive direct messages from anyone. Gimme to spam, everyone. Save changes. And if you want to know my Twitter URL, I will show it in my VM. It is that. I do not remember what that hex number is. That is my Twitter. I cannot post links in Murmus's chat, so I'll show it again at the end of the stream. I'll like plug myself a little bit more. But our RopGadgets are done, and I want to finish this exploit. Hello, AJ Rykar. Welcome to the stream. So this time, let's put this there. So let's open the gadgets.txt. Are we showing the correct? Thank you, Animawani? I don't know how to pronounce your name. Thank you for posting that. Shoot. Where? Okay, we don't need that open anymore. Where my debugger? So here's all my registers. My stack doesn't look interesting, but RBX points at a pointer to my data, so I need to deref RBX twice. Yeah, so RBX points at a pointer to my data, and then 4 bytes beyond it is my data. Okay, so I could shove a ROP chain in RBX. Let's see if we have like a move RSP RBX. No. Push RBX. Actually, that one might just exist. Or are they? Oh, yeah. Push RBX ret is going to put program counter at RBX. That's not what I want. I want to push RBX leave. Ah, it doesn't exist. I hate writing ROP chains so much. I'm good at it, but always annoyed, especially with these starting conditions. These starting conditions aren't great. Do I honestly not control any of this data? Oh, wait, R12 and R14 point directly at my data, which is useful. So let's check R12. Call R12. Aneem, is that mauve or move? Aneemavana? Yeah, I'm looking for a stack pivot right now. Bad Bytes. Just kind of clunkily doing it. I mean, I'm not going to get super lucky and have like a there's no exchange RSP. What's my regex hotkey? Control U, Control S? Yeah. Rax RSP. That's it. That's all I expected to see is exchange Rax RSP. Okay. What were the two registers I have? R12 and R14. It's R8, 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 R8. Only R8, really? What are some other stack pivot instructions? I don't even know. It's been so long since I had to do this for a CTF because Magic Gadget just works on everything. What is RCX? I wonder if I can like indirectly control any of these. Yeah, the stack is garbage. There's nothing interesting on the stack, so it's not like I could even just do like a far return. Right? Oops. SP. Like, just give me set pagination off. Telescope. RSP. X100. Oh, really? All right, I'll test that out, Sean. I was actually just thinking that. I was wondering if it was worth a shot. So let's do that locally. So these were the local ones. Copy. So then paste that right there. So we want to put libc adder plus OX47C46. That is the Rax double equals null one. Sorry, Sean, I haven't been looking at chat as much because I've been trying to get my head in the right place to write a ROP chain. It usually takes me a while to get going. It's that first gadget that's the hardest. Okay, so yeah, so that's the kind of thing that can happen if what even is that data? That's the kind of thing that happens if you use a magic gadget that's invalid. I did have an exploit one time where my system, like my parameter, was like a page of garbage, followed by backtick my command backtick, followed by I don't even know how much garbage. Amazingly, Bash interprets that correctly. So like if you just have like just nonsense and then a little embedded, hey, execute this command inside of it, it works. But don't have the capability of using that here. 47C9A. Wait, what did that one do? That one looked closer. Error code 117. Don't know why it's doing that. Don't really care. Okay, let's try this one. I saved, right? Yeah. So seg fault. Seg fault on what? GI raise? That's weird. Do I not get standard error from Pwn Tools? So I want like print r dot that, I think. File object has no attribute clean. Fine. Wait, how's standard error a file object? Does anyone know how to Pwn Tools standard error? I'm gonna Google it real quick. Pwn Tools standard error. It defaults to -2. Standard error may also be piped to use a separate pipe with a tubes wrapper. So if I do dir equals pipe and then r dot I haven't written that line of code in a really long time. I hope I did that right. There it is. That didn't work. I have no idea how to read standard error from Pwn Tools, and this is really annoying me. Process.proc. Where is this in the? That's tubes. Util. Where the heck is proc? You should not do this thing that I just did. Mod guy. I think that wrench means you're a mod. So there's a lot of weird side effects, and the rest of your code will not work properly after this. PyPony, just do logging. So I don't know how to do that with Pwn Tools. So my binary is writing to standard error, or it should be because it's aborting in LibC. And it's only 10:13. I've got another 2 hours until I was planning on ending, and we're pretty much landed this, so I'm going to figure this out now and share it with all of you because it's useful knowledge. Where is working? Wait, that's util.proc. Process. Okay. Standard error. May also be piped to use a separate pipe, although the pwnlib tubes.tube.tube, that's a name, wrapper will not be able to read this data. By the way, if you're using IPython, wait, look for pwnlib.log. Oh, you're right. I'm being real dumb. I want like that. Crap. Gotta remove that line of code. Yeah, it's a pretty sweet hack. If you're using IPython, there's actually a built-in, like, sane way of doing that. Apparently I didn't. Yeah, so it's clearly redirecting standard error to somewhere. No, that was a sigsegv. Did I change my script without realizing it? That's why I'm not getting any standard error. Wait, I'm in GI raise. I just gotta assume this is the gadget going crazy and move on. Let's try the last one. There's probably like some case it goes down. Yeah, it's another sigsegv. Yeah, none of these gadgets worked. None of the magic gadgets work. Tried all 4 of them. So it's back to trying to stack pivot, or am I just being stupid? Is there something else I can do? Arguments are passed in... Let's go back to... Actually, now's a good time to get as much as we have working on the server. So, libc base plus... I already have putcar. No, putcar's not useful. Oh, that Firefox window that I closed. I have both of the binaries. I don't know what I'm doing. So I want to, oops. Nobody saw that. I don't know what directory I was in. I should keep both of my directories, or both of my terminals in the directory that they're supposed to be in. So what I should do now, to make things easier on myself later, is get all of this working on the server. The way to do that is to point my controlled program counter at some function in libc that has a definite effect. So sleep works, puts works, anything that it's very clear when you hit it. So let's do puts because it's amusing. Can I just do xinfo ampersand puts? Nope, I can't. Okay. So that's at that offset. So if we do libc adder plus that, then it should call puts and crap out a ton of data at us. No, it didn't. What did I do wrong? What was my RDI? Wait, RDI is null there? No, that's the wrong one. There it is. RDI is 800. So let's do sleep instead. Puts won't work. Xinfo is a useful PETA function which gives you information like that. Nice for writing exploits. So that should be, we'll add sleep equals that value and then point this at sleep. I feel like I'm getting hung up on the dumbest part of this. Okay, it slept. So now I just need to get the malloc hook and sleep for this other libc. So let me quickly copy that libc to my desktop, and then where did my IDA go? Don't accidentally show things that are on my desktop. Desktop, libc, open. Okay. Now we get to see how long it takes to run the auto analysis on this libc file. Bet you this is faster in Binja, but I don't have a window capture set up for Binary Ninja yet, and oh, I guess I have Binary Ninja on my VM. So let's get this open. Open an existing file. Home CTF, live CTF. Should have landed this by now. Why am I bad? This is embarrassing. It is still going, and so is Binary Ninja. It is a race. Any bets? Will IDA finish first with its slight head start, or will Binary Ninja finish first with its actual good coding and optimization? IDA's still chugging along. Binary Ninja almost done with analysis phase 1. IDA popping up alerts. No, IDA finished. AU is idle, so head start was enough. Let's see. Binja is still analyzing, so it could also be because it's in a VM. It's not really fair. It's running inside of a VM with really screwed up mounting of the disks. I do write write-ups occasionally. I usually post them to my Twitter or like Discord or something and then forget about them. If people are really interested, hit me up on Twitter and I can dig some up. I have write-ups from DEF CON quals for a few challenges that I worked on, and some older write-ups for some challenges that were pretty interesting. Okay, so we want sleep. No, don't decompile. Sleep is at E4 870. I'm not going to switch to my VM every time I copy a value. Just know that I'm putting these in my Python script. So sleep equals OX E4 870. And then the other value that we need is the malloc_cook. Malloc_cook is 3EBC30. Now we can switch back to the VM. This is very much not going to work first try. I'll be amazed if it works first try. We can delete those, they're no longer useful. And so if this just hangs on the interactive, then I know everything is working so far. If it fucks off, then I know that I need to find the bug. Hey! Yep. So we are successfully calling sleep. So we are getting program counter on the remote server. So scroll back and look at our register context because it's kind of garbage. So R12 and R14 are the only obvious ones. There's really nothing on the stack that we control. Oh, thank you. That's funny. I feel like that's wrong. It should have cleaned that data out. So PyPony, I'm getting program counter. The reason I'm calling sleep on the remote server is, given my register context, it's the most obvious thing I can call to confirm that I'm getting program counter on the remote server. So my LibC does not match the remote LibC. So the way that I've structured my exploit, I only have to, like, these three values are the only three that are LibC dependent, but I wanted to confirm that these three values that I pulled from the LibC from the server were correct before I continued writing a ROP chain for that LibC. So because I've successfully called sleep, it would seem like it should behave differently if I make this, you know, nonsense and then run it against the remote again. Oh, there we go. Wow, Murmus's infrastructure is a thing. Good to know. Yeah, so see that EOF? So if we crashed, we'd immediately get an EOF while reading, because the server closes its side of the connection, and the Linux kernel on that side tells us that the connection's gone, and PwnTools handles that and says, hey, there's no more data. But if it's sleeping, then we just hang forever on that prompt, and we know we got program counter. So RDI, it's RDI, not RSI, that's R0 on, yeah, it has to be, because otherwise that would have worked, yeah. I always get my x64 confused. I did my initial, like, when I learned hacking, I taught myself MIPS, and then I learned Python, and eventually I learned C, then I learned ARM, and then ARM64, and then finally got actually, like, reasonable with x86 64, so I still get confused sometimes about, like, what registers are what in terms of arguments for the calling convention. Okay, so let's actually do this now. So where's the right one? Let's take you, because you are useful. Copy you, and could just move my terminal, or I could just copy paste all the data. So I'm looking for, say, R14 maybe. What can we do with R14? Can we do anything that's not pop R14? We can call R14. It'd be nice if we didn't have dep enabled. Call RBX. No. Call R14, call R14, call R14. Jeez, call R14. Wait, isn't there a feature that does like a... like... Does this work? Has anyone ever had this work ever? The tac-tac ROP chain option from ROP Gadget? Like, can I just use that? Or the PwnTools one, for that matter? I forgot these existed. I remember seeing the PwnTools one in a CTF solve recently, and I'm like, wow, I wasted a lot of time on that challenge. I should probably Google that, actually. PwnTools, ROP chain. ROP. Manual ROP. ROP example. Oh, you have to like give it gadgets or whatever. I'm sure there's some. I don't know. I'll leave it up to you guys. Oh, if you'd like me to put music on, I can put music on. And I'll leave it up to you guys. I'll leave it up to you guys. Do you want me to try using the PwnTools ROP Gadget forging stuff, or should I just do it the traditional way? I've never used it before. I have no idea if it'll work. Figure we can at least spend 30 minutes on it if you guys are interested in seeing it. Okay, yeah, no music on the stream. That's what I figured. Yeah, I'm gonna do it. I'm actually curious now if I can get it to work. So we can delete this. Well, we'll leave it there for now in case it's useful later. So ROP equals ROP dot slash what the heck is the name of the file? That garbage. Oops. That. Otherwise. Oh, I could have totally done all of those symbol things with elf. I'll rewrite it later. ROP. LibC. it's symbolic. So let's copy the local one. Dot. Did I do that successfully? Yes. Okay, and then that would be ROP with that file. And then you can also probably do like libc equals elf and the same up here. This works because I installed PwnTools long enough ago that my PyElf tools isn't incompatible. If you want music suggestions, check out literally any album by Makeup and Vanity Set, but their soundtrack for the game Brigador is personal favorite hacking music. Blue Hex, I know I've made you play that before. Brigador, it's a pretty terrible game, or at least it was on release because the controls just don't work. But the soundtrack is glorious. Synthwave, by the way. Okay, so now how does this ROP stuff work? So we can do like ROP dot let's try like how do these work? Okay. ROP dot write c dot std out file no. Wait, no, that seems lame. Why is there just not an example that does okay. ROP.execve. Okay, so then I want to do ROP.execve libc.symbols -h. Man, if this works, this is magic. ROP.dump. Oh, I should get my chat back up on my view. Makeup and Vanity Set is the artist, and the album is the soundtrack to Brigador, Brigadore. I'm actually listening to it right now. I just have my desktop sounds muted on stream. Oh, I have a typo. Sure. Oh, it's taking a while to process. It's interesting. Oh yeah, the Ori soundtrack is amazing. I think my favorite like recent soundtrack that I can think of for a game that feels like it came out recently is Fury. I didn't super like that game. Not the artist. Makeup, as in like the stuff you put on your face to look pretty. Makeup and Vanity Set. Hang on. I'll just type it out. Ready? Makeup, Vanity Set, Brigador, Volume 1. Like that. So I want to take this call and the other one and comment them out for now, because I don't need to actually be running the binary if I'm just testing the ROP stuff. So how long does this actually take to load gadgets from LibC? Let's find out. Dance with the Dead. I don't think I've ever listened to them. So what do you bet Pwn Tools is just invoking ROP gadget internally here, which is why it's going to take another like 5 minutes every time I want to do this. Can I just give it the gadgets file? Elf, ROP elf. Oh, you're supposed to ROP elf? Okay. Let's see. Yeah, it doesn't look like there's an option to just like pass it the output from ROP gadget. So we're gonna have to be pretty conservative about how often we actually run this code. Oh, key sh. But the example said that would work. What is the actual name of the libc symbol that has sh in it? Let's find out. Learning so much on this stream. I don't usually like try hard super hard unless it's an actual CTF. A lot of times I'll do things like tonight where just working on solving something and kind of taking my time and learning as I go. Trying new things. Waiting a minute for I to do a string search when I could have just hit Shift F12 and then Control F. Are any of these like a symbol? There we go. Is that symbol called bin sh with capitals then? Or is that just IDA being special? Got an hour. Get it landed by then. Which is the one that I have open? Okay, I have the remote one open. So secve. Don't I need to give it like a base address for elf? What the heck do I use? This is probably not worth it. But I don't see an obvious stack pivot, and this seems like it could work. Oh, let's see if the ROP gadget command returned, by the way. Oh, it did. You returned. From struct import pack and then do all this nonsense. Do I need to do a stack pivot? Yeah, this has to go on the stack. It needs a stack pivot, doesn't it? Yeah. Write what where gadgets, and it's syscall gadget. Dang it, I just need a stack pivot. Why is there no good stack pivot for this crash? Hang on, I'm doing a dumb. I've always just Googled this in the past, so malloc hook ROP chain. Actually, no, I'm being real dumb. I'm being real dumb. Oh my goodness, I can't believe I didn't think of this until now. Oh, I wanted xinfo. Holy cow, that Oh, I don't. Binary context. So comment out that, comment out that, comment out that, comment out that, uncomment that and that. Okay, so this works. It is something that I should have thought of a while ago. So do that, do that, that. Oh, come on. How is that not defined? Because it's LibC adder. Adder plus, I don't know what it is yet, so come on. Stop potatoing and land the bug. Okay. That seems long. So I'm going to calculate it manually. That address minus that address. Yeah, that's what I thought. That was very wrong. Copy. Okay. So that's libc adder, or I need to change this. Yeah. And then send it that. Tell it like that. Yeah, exactly what I thought. Goodness, I'm dumb. So see adder plus system. Where the heck is system? Right there. And then this becomes /bin/bash text c, or just bin bash spacebar semicolon plus. Sure, bash will probably, system should probably handle that. We'll find out. Save, right? Where am I and why is my code broken? There we go. Wait, where are you? So enter your name. We enter our name. Then we get stuff back. Then we send it a ton. Oh, because it didn't actually work. Interesting. Maybe I need to put it after? Like that? Or will that be considered junk? Does it only read until it receives non-numeric values? But probably should just check this in a debugger. Yeah, okay, it's calling bin dash now. Okay, I'm really close. I just got to figure out how to make it actually do a command there. So if I do like ls semicolon, no output. But it ran bin dash, and RDI, well, when I crashed on 4 ones from this, let's put it back to that. Do that, plus 0 times that, just to be sure we're going to do reasonable things. So the thing that I just realized is it's malloking a temporary buffer. So it's also going to call free. And it's going to have just read my string into that buffer for free. And that means I can use the free hook. Might even work with Magic Gadget, actually. But apparently, the actual technique means I can only send it numbers. Can't send it actual characters to put a command there, which is annoying. That's what I'm assuming anyway. I'm not going to dig into it further. Kind of, yeah. So RDI, this doesn't crash if I send it anything other than new, like ASCII digits. However, I can now check the one gadget stuff. Come on, stop. That LibC dot LibC tac2. What were they again? Rax null. That's not going to happen. RSP plus OX30 is null. It's not. Oh. I did it dumb. Really wish if I should probably just like recompile my kernel to make this a thing. But like if the parent process dies when I've got something p-traced, like don't kill that process. I think it's because PwnTools is sending it a sig kill when Python finishes. Okay, so Rax is always going to be A's. Like we can't, or Rax is always going to be a pointer. We can't control that. That's set, and I already checked the other two. Okay, none of those work. Man, that is annoying. Is it possible to write bash that's only numbers? No, it's not. That's nonsense. So what if I do like, where's those zeros? They're here. If I add like that to the end of it, these are going to get truncated, I'm willing to bet, because they're not numeric characters and it's doing a %. Right, I'm done. Okay. I just need to do let's just test this real quick, and then I'm officially at the point in the challenge where I've been looking at it long enough that I'm starting to make stupid mistakes. Yeah, okay, so those get truncated, However, we have a different scanf, which should also trigger the same behavior, I believe. No, because it's %s, so it's not going to. It's just going to read it directly into the buffer. All right, let's look in IDA. So close. Almost got this. I have the wrong thing open in IDA. Give me one moment. Desktop. Or no, it's in my downloads. Channel.i64. All right, back to IDA. So, what are my xrefs to scanf? I've got 3. I've got 1 in cheat. So if I send it anything other than alphanumeric character, are there any commands that are, no, because it's %d, so it's going to reject hex characters. %u? What is %u? Oh, unsigned. The format specifiers. %u. Int unsigned decimal. It's still decimal. So there's no like %x, which would give me access to hex characters. I don't know if this 19s will malloc. I'm gonna test it. Let's get our test.c open and do so car f whatever. It is specifically a %19s. So scanf %19s to f. Let's see if this crashes. But I want to be writing to the free hook specifically. Well, we'll test the malloc hook too, but gcc test.c tech o test.elf and that. Why are you hanging? Oh, because I didn't give you any characters. Nope. Oh, because I've got that first scanf, so I need to just do the thing. So 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Whatever, that's enough. No, that's what I expected. I expected %s to just write it directly into the target buffer without having an intermediary. Based on the behavior of everything else I've seen. Wait, the compilation failed? But I had ampersand. Oh, you're right. I'm losing my mind. Slowly losing my mind. Okay. Does OX19 in the format string include the null byte or the new line? I don't know. Nope, it's just exiting. It's not gonna do it. Yeah, that's what I expected. Wait, it is decimal 19? I mean, regardless, it's not gonna do it. It doesn't matter. That's the only scanfs I have. Yeah, no, so what's going to happen is the %s is just going to read it directly into the output buffer. It doesn't have to do any processing on it. It just has to read a certain number of characters or up until a new line. So no, however, this might be still good because I now have RDI pointing at my data, which gives me a whole nother set of gadgets to investigate. Which means push RDI, big ret. Do I just have a RDI ret gadget? Oh, I do. Do you have a, wait, no, I need leave ret, right? Yeah. Push RDI leave. Darn. All right, RDI. What do we got? None of these seem happy at all. Wait, I stopped actually looking at this. And Rax RDI. Yeah, okay, none of those were important. Add Rax RDI. Some more crap with Rax and RDI. Sub Rax RDI ret. And I can't do anything interesting with my stack either. My stack doesn't contain crap. There's got to be a way to get program counter from this at this point without the magic gadget. Why is this so hard? They have call gadgets. Like something like this might be interesting to continue the ROP chain. Yeah, let's see how many times that occurs in the file. Can we do anything useful before that? I don't even know what the CMC instruction is. XOR ESI ESP. That's definitely not useful, right? Yeah, not a chance. EAX, no. 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 Come on, are there any of these that aren't just garbage instructions that are useless? Have I looped yet? No, 59% through. Wait. I want to go back. Where was it? Dang it. Push RSI. What is STD? Set direction flag. Will that crash? I don't even know. I don't even know if I can execute that instruction in user mode. But RSI is not a useful pointer, so it doesn't really help. But it's close. was that last one? Nope, that's EAX and ESI. EAX, ESI. It's not, that's not useful, right? There's no way that's useful. Right, so that's not going to work. Man, I'm really struggling with this part. So let's just let's like just try the magic gadgets remotely. Maybe we get lucky with the LibC that they have. It's probably something I should have done a while ago. So I need to update the malloc hook. Let's head over to IDA. Oh, I need to be looking at chat. Goodness gracious. Oh, I have the wrong thing open in IDA again. I should probably just open them both, which is what I'm going to do now. Explorer. Hello. There we go. Desktop. LibC i64. Okay. What are you going to do? Still showing the other one, eh? Fine, I'll just close it. I have very little reason to have that open at this point. Okay. So I need free hook. Which is there. Come on, stop it. All right. Exploit.py. So remote free hook equals that address, and then let's run one gadget on oh, I'm not showing what I'm doing again. So that's free hook. Like the free hook seems better. If I could just get any characters other than numbers, we win. We're calling bin.sh. What happens if I like it won't free. What happens if I spend it like a bunch of space bars? Whatever, no. And this needs to be no, that's the wrong one. LibC6. Let's see what these are. So there's 3 of them. Small chance of maybe getting something to work remotely. OX4F2C5. And then there we go. That's the, oh wait, that one's RCX. Yeah. Now let's try it. Like sometimes my remote stuff just breaks. I'm not sure why. Let's change the code at the end of these functions to that. Might make it a little bit more reliable, keeping state with how laggy the server is being for this remotely. But I don't think this one's working. Nope. So let's try this one. Let's remove the pause. If not works.remote pause. Okay. That's at least a little bit progress. Let's try that one. Oh my god. Okay, well, we landed it. Is there a flag somewhere? So yeah, combination of using FreeHook and the last one gadget worked remotely, even though none of them worked locally. Stack was different enough from Malakuk that it worked. So I don't know if there's like a flag here somewhere. Ah, there's a flag. Am I supposed to show a flag on stream? I don't even know. Did other people that have watched other stuff? So cool, let's find out what this flag is. Congrats, you've lived once. Nice. Now I need to get root 2. Yeah, just let me drop up-to-date Ubuntu kernel Ode on AWS. That'll end well. Alright, so what did I learn? I've got a little while before I was going to stop streaming, so I can kind of look at this. I learned this stuff is pretty much useless. Still want to play around with it later, though. It might work under some conditions. Yeah, this exploit wouldn't have been too bad. I kind of wasted a lot of time in various places, just stumbling around it. Should have done this earlier. I think I was getting desynchronized, and it was not doing my exploit correctly remotely. And found a new technique, which is scanf calls. PyPony, I got it working with one of the magic gadgets. So like if I switch over to that LibC and IDA, and go to this address here, IDA, please. There we go. Right here. So moves the environ pointer into Rax, moves this into RSI, does LEA RDI, does this, and then calls execve. So if your stack is such that like this RSP plus OX70 is null, RSI will be null, and therefore it will just execute binsh. If there was something there at RSP plus OX70, it would fail. So all of these constraints failed on my local machine. But after I had the realization that I could actually get program counter in a couple different ways, it occurred to me to test these remotely again, and one of them happened to work. So it's kind of throwing blind there. But yeah, that was fun. That was a good challenge. I wish I hadn't wasted so much time. But so what do we actually use here? We use putcar. We don't use Malakuk. We don't use sleep. Clean this up a little bit. Right? Yeah. Put car. Yep. And put car in free hook. Remove all of these. Back these up. Back that up. So I like doing this kind of thing. Keeping my stuff isolated so that I just have to change a few pieces of code. These offsets on this write were trolling me so hard at the beginning. I still don't know what I was doing wrong. Like, I had a math error somewhere. I was just completely miscalculating for like an hour. Yeah. So really the only novel thing here is that, using scanf to call malloc and free, which is interesting. It makes sense that it does that, but I've not used it in an exploit before, so that's cool. Well, anyway, unless anyone has any questions, I think I'm gonna get going soon, but I'll stick around to answer questions for a few minutes if anybody's wanting to ask some. Nice, Sean. I'm probably not the best person to ask PyPony. In terms of like useful resources on the web. There's like maybe a couple that I recommend to people, but my recommended way of like learning this stuff is play CTFs. Like, just whenever there's a CTF, try to land a binary and then read the write-up and see what you were missing, and eventually you'll amass the knowledge. Like this thing about scanf, I'm gonna remember that forever. Like, I'll have that in my back pocket for challenges for the future. The royal flush code is broken and impossible to actually trigger. Huh. That's kind of funny. I actually never looked at the scoring. We could look at the scoring algorithm now, but I really don't want to. It looked pretty gross, and you can just ignore it completely. So yeah, I don't know PyPony. Maybe like start with a Stack Overflow and work from there. Title grid. I don't know. I'm mostly just like talk about the stuff and play CTFs with like coworkers and former coworkers. So like none of those are public communities. There's like pound pwning on Freenode used to be a thing. I don't really IRC, so I don't know if anyone actually hangs out in there anymore. But that used to be a pretty active CTF channel where a lot of really good hackers hung out and talked about doing hacks. Trying to think of what else. Yeah, I'm not sure. Yeah, this was fun. I'll definitely take part again if Murmus runs this challenge style thing again. Maybe I'll even write a challenge for it sometime. "2 hours from Washington, D.C., and there's not many security jobs." I mean, it depends on what direction, but that area there's a lot of security jobs in like the DMV, Nova type area. Just, I guess it depends on what direction from DC. I'm curious how reliable this is. So if I do like, can I figure out, if I do like r.sendLine cat / home/shell/flag, and then r.receiveAll. I want like exit. Yeah. Oh, I should print that. So it is reliable. So it depends, PyPony. Doing vulnerability research and exploit development for a living is a lot different than playing CTF. The actual hard parts of it are very different. When you're doing VR for a living, you spend months or years at a time staring at one piece of software maybe and never finding a bug. Like you don't know the bug is there. With CTF, you always know there's a bug, right? I could look at Chrome for 2 years and not find anything, and I don't know if it's because I just didn't see it or there wasn't any bugs in anything I looked at, right? So that's a lot harder to deal with in the real world. And a lot of these like exploitation tricks and stuff really don't come into play. They're mostly just for CTF and like proof of concepting stuff. But the skill set, the seeing the BSS out of bounds right and knowing how to turn that into an info leak, like that kind of thing is still useful. But tricks like, bashing, tricks like the magic gadget or things like that tend to be a little bit less useful. Like I still have never seen a good CTF challenge that involved doing a heap groom, other than like the ones that are here, pwn our browser, which like is not isolated enough for me. Like it would be interesting to see a challenge that exercises that thing, like doing a heap groom without having to know so much else about some kind of exploitation, like browser exploitation or kernel exploitation. Like there's a lot of stuff that you learn doing it in the real world that doesn't apply to CTF and vice versa, but some of it is relevant. Nice. Only one memory corruption bug. So were all the others like integer handling or like null derefs and things like that? Oh, Rust panics memory exhaustion. Okay. Yeah, I'm not super familiar with Rust, so I don't know a lot of like the primitives involved. I've never like landed a Rust bug, for example. It's kind of on my to-do list, but I don't know if I'm ever going to get around to it. R2 as in Red Air 2? See, I'm missing some of chat. I wish I could make chat bigger. That didn't make chat bigger. Let's see. Got into the cybers in college. Other people just started with dev. Yeah, my path into doing VR was a bit unusual. Like that's what I started with. Back when I was a very small nooblet, someone gave me a disassembly of a kernel driver for the PS Vita, and I printed it out because I had restricted computer time at the time. Like I was only allowed to be on the computer for like an hour a day. So I printed it out, threw it in a binder, and carried it around with me for 8 months, learning MIPS by hand. had a little like MIPS reference in the front, writing notes all over it. Eventually found the bug, learned how to exploit it, and yeah, so that was like the first thing I did. I wrote that exploit in MIPS assembly. Like I didn't even write it in C, because I didn't know C at the time. I am not a graduated student, PyPony. I was briefly enrolled at USF, but I never took classes. There are a lot of things that I wish I had gone to school for, like some of the more formal CS stuff, like algorithms and data structures and that sort of thing. I'm pretty weak on. But at the same time, like the reason I didn't go to school is right after I enrolled, I got hired to do this full time. So, yeah, that's true. I don't really know where I stand on it. I don't have a strong opinion on CS degree or not. I think a lot of CS degrees are garbage. Like you get a lot of people with a CS degree that don't know anything about computers. Like if your systems internals class uses Java, which is an actual thing that I heard about, they were learning systems internals. Like it should have been like a low-level assembly programming class, and they were using Java. Like yeah, you're not gonna come out that strong on the other side if you've literally never seen assembly. Like I pulled it off. I was able to succeed and be pretty happy with where I am 4 years later. You know, just dropping out of college to go into the workforce, but might not be for everyone. I also have been doing like hacking stuff as a hobby for most of my life. So there's a lot of nights where I'll like sit down and throw 50 lines of C together and try to exploit it. Yeah, mod guy, that is true. I think I've picked up some now along the way because my work has been a little bit more dev focused for the last couple of years. So I've like read a couple textbooks and kind of taught myself, but I still think classes would have probably been helpful there. How helpful, I don't know, but helpful probably. Now I'm really curious to check out the other streams. Oh, you get to learn C in high school? That's awesome. Yeah, Sean. There have been many occasions where I had to build a bleeding edge GCC because my C would not compile on older versions of GCC because it would core dump the compiler. Currently a CS student in your first year, junior full stack, trying to dive everywhere in security until you dig into a subset. So one thing to keep in mind is there are two very different things that people mean when they say computer security. They can either mean this kind of stuff that I'm doing, which is much rarer that they mean that, or they could mean like operational stuff, like sysadmining, knowing how to secure systems, which is much more common when people say computer security. So, you know, keep it in mind. I'm not a big fan of all of that. I literally don't know how to use computers. I only know how to break them. If something on my Linux machine like breaks, I spend hours on Google trying to figure out how to fix it. It's not pretty. C++ as C with a better standard library. That is one way of looking at C++. That is definitely a way of looking at C++. I'm not a big fan of C++. I've never really enjoyed writing it as much as I like writing C. Although I have a feeling I would enjoy like templates and the real nonsense quite a bit, because it's the kind of code that I like to write, which is unreadable code. But yeah, too much work. Where? Oh, here, -0x78. So the symbol that I'm reading, so the pointer that it gives me, is hex 78 bytes into the BSS section. So to get the base address of the BSS, I subtract hex 78 from it. That way, when I do my calculations later that are based on the base address of the BSS here, I could have just subtracted 0x80 plus 0x78, or done both of the subtractions down here or something. But typically, the way that I write my exploits is if I have a global, like BSS adder or LibC adder, it refers to the base address of that segment. And then all of my other calculations will be referential to the base address. I find that helps me organize things better and not get lost in offset hell like I did when I was trying to get the info leak working. Like, to be fair, this looks very different from an exploit that I would have written in a real CTF. In a real CTF, this would be 200 lines of nonsense, because I'm rushing and not really caring how quality it is as long as it works. But I was trying to set a good example here and like actually have some standards. I can so seesaw, double trouble. So like compare that to this exploit that I wrote at Seesaw that was a couple weeks ago, which is just like the most nonsense garbage I've ever written. Literally the most nonsense garbage I've ever written in my life. This challenge was so stupid. But like, this challenge still makes me angry even after I solved it. Yeah. But so I don't know if I agree with that, Sean. I wouldn't say they've gotten harder. I'd say they've gotten different. Like, the knowledge base that you needed to be really, really good at CTF 4 years ago when I started is very different from the knowledge base you need to be very good at CTF today. Same with the skill set. Especially in the last year, CTFs have shifted a lot more towards having a lot of like open source projects in their challenges, having a lot of like weird blind guessing stuff, and it, like, I think it's probably accurate to say it's harder, but in the past several years, Sean, like when I started playing CTF, there was definitely not executable stacks and no heap stuff. Like, my first CTF had like definitely had heap stuff and like real exploitation. Have I found Ode? I have found plenty of Ode. Not much that I can talk about though. It's NDA from my old job. Okay. Yeah, I started around the time when heap stuff was not the kind of heap stuff you get today. It was more like just like recognizing what obscure heap technique you needed to use, or like type confusion or other things like that. And then as everyone started to get the hang of like, okay, I instantly recognize what technique I need to use, you started getting what we get today, which are the super constrained heap challenges. Like there's a challenge from Tokyo Westerns that I still haven't solved, called Barbecue, which was an incredibly constrained heap challenge. You had an arbitrary free if the OX 18 bytes after the pointer that you wanted to free was a magic value. And you had like no way of, like, they were using stirdup, so all of your data that you could write to the heap was terrible. Spectre Meltdown. Yeah, I did read quite a bit about it. One of my interests is CPU internals, so less these days, but if you were talking to me like 2 years ago, I could spout off about how ARM CPUs worked internally. And I mean, it was a pretty big deal. If I recall, like, Spectre was just arbitrary read memory no matter what, like through the hypervisor, through virtualization, through the kernel. It's like your privileges are nothing, you can read it. And Meltdown was the same but for writes, but I'm not 100% certain on that. It was a fairly big deal, like to the point where like that whole family of bugs. So Spectre and Meltdown are part of the speculative execution bug class, where the CPU actually looks ahead at instructions that the program counter is not at yet, and will pre-do some of their operations and like load them into memory and do lots of weird things to optimize so that by the time it gets to that instruction, it's faster. The problem is you could manipulate that behavior to cause the processor to essentially make a wrong prediction and leak you information about memory that you should not have been able to read. And it's kind of a core flaw with speculative execution. There are papers that are saying that, you know, the next several generations of CPUs are going to be like set back by significant percentages in terms of performance because speculative execution speeds up your processor a lot. But there's really no way to secure it. Like from a fundamental standpoint, there are these fundamental flaws with the way that it was done. Which is why the Spectre patches were such a huge performance hit when they first came out before people started trying to optimize around the changes. Sean, I don't know if it was actually Spectre or Meltdown that had the writes. The writes were in the same like family of bugs. Like Intel had like so many bugs I stopped counting. Like just one after another as soon as somebody realized how broken some of the stuff on their CPUs was. Let's see, what time is it? Oh, we got another half hour before I said I was going to get off. I'm good. Yeah, it is very complicated. Like I gave basically a layman's explanation right then. Bogus and blown up by the media, so Microsoft had to patch it. Yep. That sounds like a high-ranking secure systems architect for just a company in general. Yeah. Those are the kinds of bugs, like, I've said for a really long time, like, I would literally sell my soul for the source and, like, full documentation and internal resources about the Intel microcode. Like, it would be incredible, the stuff you could do if you actually knew how that worked. One of the best kept secrets in technology, period, is that stuff. Like, that's held as tightly as, like, I don't know, Apple signing keys or something. Amazon and servers definitely patched it. Part of what Spectre allowed you to do was read memory from other virtual machines on the same hardware. So the entire virtualization and cloud industry would have been like annihilated. Imagine if I could just buy a server on AWS and start reading other people's credit card information. Like, well, so Sean, I don't have a PhD in CPU architecture, which is what you need. In order to even get near that, I would need a PhD in CPU architecture. I don't have an interest in getting a PhD in CPU architecture. I want to learn just enough about it to write a bunch of ODE and get famous, and then never look at it again. But yeah, so like the biggest impact from Spectre, honestly, was cloud providers, because they lost a ton of performance, and they can't not patch it because it breaks the entire virtualization model. I mean, we could test. I've got a shell on an AWS server right now. I could just pull down a Spectre POC and see what happens, but I don't think I really want to be running super malicious code on Murmus's AWS account. Pay someone else to get a PhD and have them steal it for you. Cloud gaming? Do you mean like multiplayer games? I have found and exploited vulnerabilities in multiplayer games before. I think only like twice. I had remote code execution in this MMO that I used to play, and the other one was like command injection or something in a server, an anti-cheat or like an anti-aimbot plugin for a Quake mod. It's not strongly in my interest, but literally any software can be hacked. If your software takes input, processes it, and produces output, and is of sufficient complexity that it is not like cloud gaming that are games in the cloud. Oh, like PlayStation Now? Like maybe if you managed to get your hands on the PlayStation Now like endpoint source code or like something and found a bug in it and were able to throw from your PS4 to like I don't think it would be that interesting. Like there are easier ways to get free games than hacking Sony or whoever the cloud provider is. I don't know if I fully understand what you're saying though. I honestly don't know Title Grid, partly because I haven't looked. Like if you go and look at so GeoHot, that's a whole kettle of worms. They hacked the PlayStation 3, so they didn't actually exploit Sony. When I say exploit Sony, I mean like Sony controlled servers. Once you bought a piece of hardware, like I used to do that, I hacked the PlayStation Portable. Like once you bought a piece of hardware, you can do anything you want to it, but they are more than you think. Animowani. Look at say like on the Wii, the way that you'd get initial code execution was through modifying save files. We did literally hundreds of those for the PlayStation Portable. Like, oh, it's got a name field. Oh, the save isn't encrypted. They're not checking the length. Boom, Stack Overflow. Like hundreds. Some of them got a lot more complex as time went on, and Sony was actually catching on and patching games. Oh, through button presses. There's more synchronization behind the scenes going on than that, right? Because you've got to account for like network jitter and so I don't actually know how, say, PlayStation Now, for example, works. But they are almost certainly not just streaming button presses to the server and then streaming video to you. That would be way too high bandwidth. What they're probably doing is they're probably streaming the resources for the game to you in such a way that you can play the game without actually ever having the entire game. Like look at what games are available. They're mostly older games. Like you're not streaming PlayStation 4 games. You're streaming older PlayStation 3 titles and that kind of thing. And with a little bit of like optimization and some clever hacks, you could totally do that. Or they could be doing what the Vita was doing. So the PlayStation Vita, you can remote play your PlayStation 4. And what that does is it pre-computes most of the game on the PS4 and then streams I forget the term for it, but it's like a partially encoded video. So the GPU on the Vita can like finish the processing and do the final like render stages, so they cut down on the bandwidth a ton. And it worked brilliantly. They could be doing something like that as well, where they're just sharing the compute between the two. But I honestly don't know the technology behind it, so I'm kind of just talking out of my ass. But title grid, to answer your question about salary cap for ODayers, if you look at like what a full chain iOS exploit is worth, like let's see, like Zerodium pays up to like $1.5 million for certain stuff, and that's just the first thing I found on Google. Like depending on what you find, you could make a lot of money, but you also got to consider that you're taking a big risk. Like if I had the money, I could take a year off work and go find like a bunch of Linux kernel ODay, almost certainly, and try to sell those. But like I don't know how much money I'm going to make from those. I don't know if I'm going to actually find anything. Like, and then you've got that initial investment of not having a paycheck every, whatever your pay period is. Like I know some people that have been pretty successful with it. But it is definitely kind of all over the place. Steam streaming works. Yeah, I would believe that streaming on LAN is just video streaming because you're much less bandwidth constrained, I mean. Where is it? So like, I wanted to pull this up at some point before everybody leaves. This is an exploit I've been working on. This is what a real CTF exploit can look like. This is 164 lines of code just to get info leaks. So this exploit is nuts. If you're looking to work on a very difficult binary, I strongly recommend checking out Barbecue from Tokyo Westerns. That was a couple months ago. But like there's this series of yeah, Pypony. So ASLR randomizes the base addresses of everything in memory. So information leaks are getting pointers to stuff, so you know where it is. So like this leaks the heap, and then LibC, and then the stack, and then the binary. But like there's this sequence of allocations right in here. Oh, you're right. I also get the stack cookie at some point. Where did I do that? I don't know. Might have been the last thing I did. Yeah. I haven't looked at this in a little while because I got really frustrated with it. Like there's large sections of this. I know what I want. I'll show this off real quick. CTF, Tokyo Westerns, Barbecue, whoops. So what happened to my terminal? What the heck? Oh, I'm in full screen. There we go. Okay, so if I do, that should pause. Nope, that's remote. I don't know. I was going to show what trace malloc looks like, but apparently I left it in a state where it's working on the remote server, so I can't. But yeah, it's just like hundreds of mallocs, and for like long chunks you'll just see overlap. Trace malloc is a feature of Angel Heap, which is PwnDebug's heap extension. It's quite useful. I would recommend looking into it. But yeah, so it's pretty much time for me, I think. Don't really have much more. That was a ton of fun. I can't wait to look at how the other people solved it or didn't solve it, and to talk to Murmis about how my solve worked tomorrow. I'm gonna head out. Everyone have a wonderful night, and yeah, hopefully see everybody around for the next one of these. I can't wait. Am I going to talk on stream? What do you mean, am I going to talk on stream? Probably not. Although I have been considering starting up doing some of this myself. So keep an eye on my Twitter. Don't know if I'm going to find time. I also stream video games like 4 days a week. Yeah, but keep an eye on my Twitter. If I may come back with some more streams, some like recap stuff, exploit stuff. We'll see. So yeah, thank you so much, everyone. It was great.